Dear students, in this video we are going to see examples and counter examples and a few properties of group and abelian group. Okay. Now you see here example 1. Is it Q or C? What is it? Set of all integers. This is set of all rational numbers. This is real numbers. This is complex numbers. Okay. You take the binary operation addition. Addition is see normal addition. Okay, usual sum. What is given here is that the Q or and C are abelian groups It's correct over this addition, over the binary operation addition. Okay. If abelian group means what we know that five properties are satisfied. That is closed, associative, identity, inverse, and then commutative. Okay. See, out of these 5 properties, closed and associative and commutative means simple to prove. Okay, it is easy to understand and prove. Okay, but especially we have to see how to find the identity element. What is the identity element in any group or abelian group, and how to find the inverse of any element in that group. Okay, so now here we are talking about that in this example. Okay, now what is the identity element? Identity element is 0. See, when you take the binary operation as usual addition, definitely the identity element is 0. Okay, so that here identity element is 0, that is 0 identity element. Okay, now we can say means identity element or neutral element. Okay, now how to find the inverse of any element? Suppose I take a is equal to -7. See here, suppose I take a equal to -7. Okay, then how to find the inverse of a? That is, see here what is given in the example. Inverse of any element a is -a. This is given in the example. Okay, why? Because of the binary operation addition. See, this we have seen in the previous video. We have proved that z comma plus is an abelian group. Okay, and then we found the identity element is e is 0. And we found what is the inverse element of any element, that is -e. Actually, we have proved in the previous video. Okay. Now, so what is the inverse element rule? How to find inverse element? A inverse. This is the inverse element is equal to find the inverse element of A is equal to minus that element A, which means here I take A is -7. So A inverse is equal to minus of -7, that is 7. So now listen. The element is -7. What is the inverse? 7. Suppose I take A is 5, then inverse is -5. Okay, this is this value I taken in Z. You take in cube, for example, 1/3, 1/3. A is 1/3. Then what is the inverse of A? -1/3, because here binary operation is addition. Binary operation is addition. Whenever you operate the element and inverse element by the binary operation, it has to give the identity element. Okay, so according to that, by using this rule, you have to find the inverse. Okay, now you see the example 2. Here q -0, we can read as q -0. Here rational number, set of all rational number, but 0 is not considered. 0 is deleted. Third set we take. The second set is r minus 0. Third set is c minus 0. Okay. Now here, what is the binary operation? Multiplication. And here in example, it is given that these 3 sets are abelian groups over the binary operation usual multiplication. Okay. Okay. You have to remember that whenever you see the binary operation addition, definitely the identity element is 0. Whenever you see the multiplication as a binary operation, your identity element is 1. Okay. Okay. Now, so what is the identity element? 1. Okay. How to find the inverse? Identity element is okay. How to find the inverse? You see here, inverse of any element A is 1/A, which means, see, this is the rule for inverse. Okay. For example, I take A is equal to 4/3. Okay, then how to find the inverse? A inverse is equal to 1 divided by A. This is the rule. 4/3. So you put the reciprocal of this, so 3/4. So what is the inverse? Inverse is 3/4. What is the element? 4/3. Okay, how to check the inverse is whether right or wrong? See, you take the element A and the inverse of element A is 3 over 4. You multiply these two, 4 over 3, multiply 3 over 4. Definitely the answer is 1, identity element. It will give identity element. Therefore, inverse is correct. Okay. Now, we will see one new definition. Addition modulo. Okay, addition modulo n. Okay, here 5 addition modulo 4 7 is equal to 0. You see few examples. How to find this? See, first you take the number, first number and second number. 5 7, you add 5 and 7 is 12 first. Okay, here what is given? 5 addition modulo 4 7. Okay, first you have to add, that's why I am doing 5 plus 7 12. Then you have to do this modulo 4. Modulo 4 means what? You write this 12 as 12 is equal to 3 multiply 4 plus 0, because here 4 divides 12 exactly. So what is the remainder? 0. Whatever you are getting as a remainder, you write it here. That is your answer. Very simple. What you do? First you add 5 and 7. You see this sum means what is the value. Then write like this. Then write the remainder here. That is your answer. Similarly, you do here. 2 addition modulo 6, 3 is equal to 5. Okay. Here 2 plus 3. First you add, that is 5. But 5 is a smaller number than your modulo. Okay. So if you divide 5 by 6, again you will get 5, because if you divide the smaller number by bigger number, you will get the same number as a remainder. So 5 is your answer. Or you can write like this. 5 is equal to 0 multiplied by 6 plus 5. Okay. See the third example. 4 addition modulo 5 9 is equal to 3, which means again 4 and 9 you add first 13, and then you apply this modulo 5, so that I can write 13 as 13 is equal to 2 multiply 5 plus 3. Here what is the remainder? 3. That is your answer. What is the remainder? That is your answer. Okay. Multiplication modulo. Yeah. Okay. Similar idea. Instead of adding, we have to multiply. See here, 5 multiplication modulo 4 7 is equal to 3. How? Take the first number, take the second number, you multiply both. So 5 multiply 7 is 35. Then write this 35 as 8 multiply 4 plus 3. Why? Because 4 is your multiplication modulo 4. So you try to write 35, the product of 4 multiply some number, then if you have remainder, then write the remainder here. This remainder is your answer. This remainder is your answer. Okay. Only one difference is first you have to multiply, then you have to write as a write in the form. Okay. So now here 2 multiply 4 8. Then you write 8 is equal to 1 multiply 6, because here 6 is the modulo. Okay. So try to write 8 is equal to 1 multiply 6 plus 2, and 4 multiplies modulo 5 8 is equal to 4 8s are 32. First you multiply, then apply this modulo. Okay, apply this modulo, so that 32 is equal to 6 multiply 5 plus 2, so that here remainder is 2, so your answer is 2. That's it. This is multiplication modulo. Okay, now you see few more examples. Zn addition modulo n is a commutative group. Okay, where Zn, how to write Zn, how to write elements of Zn is simple. Now you see 0 1 2 etc n minus 1. Suppose here I am writing Z7, then I write 0 1 2 3 etc 7 minus 1 6 until 6. Okay, here what is the binary operation? Addition modulo n. Okay, whenever you have addition, you remember identity element is 0. Okay, what is given here? Identity element is 0. Okay, but here how to find the inverse? Okay, how to find the inverse? See, how to find the inverse? This is the idea how to find the inverse. That is, inverse of 0 is n minus 0. We will use this rule. Actually, we are going to do few questions on this, so that time I will explain this one. Okay. So here very simple, Zn comma addition modulo n is a given commutative group over the binary operation addition modulo n, then the identity element is 0. Then how to find the inverse? by using this, inverse of any element 0 is nothing but n minus 0. See, if inverse of b you need to calculate, then apply n minus b. Okay. Now, you see the example 2. Let p be a prime number. You know what is prime number? 2, 3, and then no 4, 5, and 7, no 9, 11, etc. Okay, etc. It will go. That is called prime number. Okay. Similarly here, zp minus 0, which means now here you delete 0, then you write the elements of zp minus 0 from 1, 1, 2, 3, etc. until p minus 1. Suppose here your p is 11, then you write until 10. Okay, you use the cap symbol. Okay. Now here what is the binary operation? Binary operation is multiplication modulo p. Okay. Now see, whenever you have the binary operation multiplication, your identity element is 1. That is called neutral element. See, no doubt, identity element is 1. Okay, identity element is 1. Okay. Now, how to find the inverse by using this idea? Okay, this also I will explain when we do the question. Okay. Now, you see the counter examples. Counter examples means which are not a group, which are not a Boolean group. Here we see few examples. Okay, now you see here z minus 0. See, z minus 0. In set of all integers, suppose if we leave 0, okay, with the usual multiplication as a binary operation, is not a group, since there exists no a belongs to z minus 0 such that a multiply 5 is equal to 1. Okay, which means what they are trying to say, trying to tell. Actually, you cannot find the inverse, because suppose you have 5. Suppose you take 5, a is equal to 5. How to find the inverse? How to find the inverse for multiplication? If you find the inverse for this element, then if you multiply the inverse and this, it has to give 1. So that inverse should be 1 by 5. But you cannot find the rational number in the integers, so that it is not a group. Okay. Similarly here, q comma dot. What is q? Rational number, and dot is normal multiplication, binary operation. Then here 0 has no multiplication inverse. Yes, for the element 0 you cannot find the inverse. Okay, so that here it is not a group. Okay, what is n comma plus? Okay, n is set of all natural numbers. Yeah, this is addition, but n starts from 1. Understand? 1, 2, 3, etc. Here there is no identity element, because addition having the identity element 0. The identity element for addition is 0, but here in this set no 0. Therefore, it is not a group. You see now the property 4. Now zp minus 0 over multiplication modulo p. Okay, is not a group. Is not a group. See, here p is not a prime number, which means you take p as 4. Okay, then elements are 1, 2, 3. This we know that. So 0 you delete. See, z4 minus 0. So 1, 2, 3. See here, for 2 multiplication modulo 4, 2, answer is 0. Okay, if you apply the binary operation for this element 2, your answer is 0. But 0 is not in this set. It is not closed. Even it is not satisfying the closed property. What is the closed property? If you take any two number, apply the binary operation, the answer should be in your set, but it is not. Therefore, even it is not satisfying the closed property. So it is not a group. Okay. Now these are the counter examples. Okay. So we will see a few properties and few more questions in the next video. The continuation of this lecture we will see in the next video. Thank you.